Hey guys, we are gonna talk something very different from typical UI side of things, and we are specifically talking about like how do you do analytics in the browser itself. So can you raise hand? How many of you are like front-end developers, like UI developers? So almost all, right? We are on a React conference, but how many of you are also developers? Because you are also developers, right? So now, like this, we will talk something very specific that's a typical analytical part of things where we will talk about databases a lot, but it's all in the context of the browser. So one of the thing that we were starting is I was preparing for this talk, and I was thinking, should I spend time on explaining the databases concepts? And I'm not talking about SQL databases in general. How does that like warehousing and all works, or should I go deep into the code? And one of the thing I decided was let me explain them and explain why does it make sense to do it in the browser. And I don't know if I would be right because I will be giving you a lot of theoretical concepts, but I will learn, and next time maybe I will not do the same thing. So with that, let's get started. I'm Nikhil Talwar. I lead the front end team here at DevRev. I'm one of the founding engineer with whom we started DevRev. I love building data intensive UI applications and visualizations too. So prior to that, I have also spoke in React India to build complex visualizations using D3. So in case you can find them on YouTube if you want to learn more on that. So actually, I want to show you first before I even talk, like what does in-browser analytical means, and I will jump to this particular demo. This is the app. It's basically it's a DevRev app where I work, and you see there's an analytical dashboard here, and I will just hit reload. Um, okay, I mean it is taking time to reload. But let's observe one thing, like the time you see this widget, how much time did it take to get this data in the UI? And one more thing I will say that I will apply a created by filter. Let's say I talk Prithvi as filter, and I will show you when I click it and try to see that, can you see a loader? I mean, did you guys see a loader? No, right? And now, so what if I tell you there is around a millions of rows behind this particular UI that is doing it, and we are not talking to the backend. It's happening in the browser itself, and I'm not using any server-side compute for it. And this is what we will talk. How did we started building this, and how it might be applicable to you also. So does it sounds good now? Okay. So a bit about DevRev. It's an ad break. Basically, at DevRev, what we are trying to do is that we are trying to get different kinds of objects. For example, your work that you do on issues, the ticket that your support agent works, and your product manager works on road mapping, and also your salesperson is working on Salesforce for building opportunities and things like that. What we are doing in DevRev is that we are making one, we call it as one CMS, where one CRM, where we get everything into one single place, and we can go and do a lot of basically as a developer, you know why something breaks, who is selling what, and things like that. You can look at devrev.ai to learn more. But I'm going to specifically talk about analytics and why analytics is important and why did we choose the route of running things in the browser. Because traditionally, if you are building dashboards, you are probably thinking that this queries that happen on the server side is not happening on the UI. In fact, nothing happens on the UI most of the time. It's all get the data, render it out. So one of the thing in DevRev is that we want to make a view where, let's say, like a like I said, support agent or even a developer can know what exactly is happening in the company. And for us to work with so many objects, we have to build a relationship between them. And the relationship is like how an issue flows into tickets and how a ticket is flowing into customer, and how a customer is making revenue for the company. So all of this data resides in DevRef. And one of the ideology that we have is that we want a lot of our freemium customers to come and start using DevRef, and after some time they will pay us. But this brings up an interesting challenge for us that we can't keep the running cost high because we want people to come and use the app and not paying so much, basically not like flooding the dollar amount just to run our servers. So this is one of the challenge we have that I will repeat. We want to keep our compute cost extremely low so that we can give this feature to lot many people for free, almost for free. So with that challenge, we'll go forward and let's talk what the duck is wrong with analytics. In basically the traditional analytics today, how many of you have actually used or like you have built an application where you're talking to a data warehouse and building visualizations on top of it? For example, a line chart, bar chart. Can you raise hand? Or at least you relate to this problem statement. So one thing that you would have heard your backend developer saying that, hey, this will take a couple of seconds to run, right? Like this is a very common thing, and people keep fighting with design team. People say that, hey, I will add some level of caching, put it in Redis and all of this thing. But primarily there are three reasons for the slowness in analytics. One is actually the cost, and we'll talk specifically about cost, how expensive it is to run an analytical big Q servers versus the the amount that you want to spend running the queries and the concurrency. So these are the three pillars of the problem statement. That is the time it takes to run a query, how much money can you pump in for running those query, and how many people can run the same query in parallel. This is the typical problem statement with analytics, and a lot of people are trying to solve in various different ways, but I will tell how we are doing at DevRef.
I mean, my argument it need not to be, and something that is very popular who proved this thing was in the last decade was Figma. So in Figma, the 90% of the customers are free and only 10% of the customer pays. So the 10% of the customers are paying for those 90% because Figma on the server side is just a storage, and every single compute happens on your browser, it's on your machine itself. And you would have heard that I'm doing something on Figma, you sometimes have to close it because it is so much like memory and process heavy operation. You could relate to that. I mean, it's not that they want to keep it this way, but this is how their business model makes them operate. And they are extremely profitable. They are doing extremely well. They even got acquired by Adobe, but then they say that no, we can't for legal reasons. So far, are you guys with me on the ideology of why things can happen on the browser, and the browser need not to be dumb? I will quickly explain. This is a very simplest overview of how we do analytics in DevRef. And one thing that it might sounded that I was saying that you don't need Snowflake or you don't need any big data database. No, you do need it, but you don't need it that much. So if you see, what we do in DevRev is that we have our big queue, which is Google's big data storage. We run summarize job and put it in S3 files. And these S3 files are Parquet files. Parquet is a very compressed columnar data storage, which is more optimized for doing analytical data queries. From there, what we do whenever the client asks to run any query, we download these files to the browser, write them inside the index.db, and then whenever you want to run the queries, we pull it from the index.db, run the query in the wasm, and then execute the queries. And this is exactly what we did in the first demo that I was just showing, that this is exactly what just happened at that time. Okay, so we developed something, an open source SDK for you to, if you want to do all of this thing in the browser itself. And this is the repo. In fact, this got open source just like 5-6 hours back. I was begging with my infra team, be like, please make it open source. We want to go for a talk. And I mean, they are good guys and they did it. So what does meerkat does? And first of all, why meerkat? Do you guys know this animal, meerkat? Okay, it's typically found in African region and in zoos of rich countries. It's a small cat. It's not actually a cat. It's like a mouse with which looks. I find it really cute with dark circles and feels like a developer, a small guy over here. Yeah, just like a yeah, and they are really cute animals. You should look at them. They usually goes in a group. They mostly sit in a sunlight, sleep, and I find them really cute. So yeah. So what does Meerkat does? What basically Meerkat does it takes your semantic language. When I say semantic, if you look at this example, that I was applying a filter and it was converting that filter into a SQL query. So all of this logic is taken care by the Meerkat library, where we convert the user's ask into a SQL query and even sometimes join different tables to answer them. So for example, your table is not having a data that you want. What it does is it figures out which table to join and then run the query. And apart from that, we use DuckDB AST to basically construct the SQL queries. And basically, there are two ways of generating SQL. You can either do string concatenation, or you can write into an abstract tree. Basically, SQL is also semantics, and you can de-tokenize it, and we call it as AST, and then serialize the data again. And on top of it, it manages how to write things to IndexedDB, when to pull it from IndexedDB, how to expire the files. And also, when we are using a lot of memory, it basically removes the memory out of the Meerkat too. So I will show you this Meerkat piece in action. So I have like this is just for internal use that we ask basically developers to use for generating widgets on the right side. So if you look at it, I'm saying that from this particular table, I want to know the account ID, and the next column I want is the total number of accounts, and I'm saying in the table how to plot them. And just by this much information, we were able to generate this particular table. And I can show you applying any kind of filter. Let's say I apply severity filter and I say severity low. The query execution happens in like, I think 20 to 30 milliseconds. Imagine 20 to 30 milliseconds to apply filter. If you talk to your backend, if your backend even pulls it from its locally, the network cost is maybe 5x or 10x from that. So you can't get low latency than I think 200 milliseconds, no matter what you do, until you're serving it from edge functions, for example, Vercel or something. But the compute has to happen in 200 milliseconds. So this is it can't be faster than this. And if it does, like it's also like I will do it then. Okay, so I want to take some examples, like just showing that the Meerkat capabilities. I change the, not used to doing it with one hand. Okay, so now we just plotted like the stages of a ticket into a bar chart by just saying that in the I want to do group by on stage ID and do the same count. And I'm saying get me a bar chart and put a stage ID on the x-axis, and on the y-axis put this value. And this particular library takes care of everything, converting into the SQL, executing it, pulling it from the IndexedDB to answer your queries. And just like that, I will show you an example with a line chart. Now, with just saying that on every single day, show me how many unique IDs were there, and just making the bar to line, we are able to plot that. And all of this happens all in browser. Okay, so we did some like very simple benchmarking over here. We have three queries, which is on very classic data set, which is New York taxi data set, and we are trying to run queries in an extra small Snowflake warehouse versus running it in my browser in my machine. How much is the difference? My machine is a M1 Pro, almost 3 years back, 3 years old machine with just 16 GB RAM. And this particular machine is maybe twice expensive and also twice powerful than my laptop. Still, the execution time is 1.2 seconds, and the same query takes 200 milliseconds in my machine. And similarly, you can see one thing I think there's a difference is that over here it was faster, and over here it is taking more time. But what does Snowflake does it also caches a lot of things when it runs the query. So I know we will get there, but at least if you see, we are not very far, and sometimes 100x better than Snowflake also. Okay, so now a question that you guys will be like, hey, my backend developers keep saying that my data is large, like we are talking about petabytes, terabytes, GBs of data. I can't get it in the browser. So there is a separation between compute and storage, as I was talking. And also, most of your data is just gonna sit. Anything that is beyond 2 months, nobody's gonna look at it. And you can go and try to check this out. And this is one of the things that Google BQ person mentioned too, that one of their VPs, that most their income happens from the storage, not from the compute, because people bring petabytes of data, but they never query it, because data is a liability to the companies, that I can't get rid of the data, I can't get rid of the logs, because in future customer ask me those information, I need to give that data back. But that will actually never happen most of the time. So, and with that, so you might think that your workload is high to query petabytes of or GBs of data, but this is a stat from Google BQ. 99 percentile of the queries happen on only 10 GB of data. And you can get that 10 GB of data easily in at least in your system. I'm not saying in the browser, but 90 percentile of the queries only happen on 100 MB. And the examples that I was showing, I was using 400 and 500 MBs of data while running those queries. And a lot of time you might think that, like, hey, no, my backend developer says that we are actually using like GBs of data even while running this query. I mean, no matter who says that, I don't think that's possible, because your query will take minutes to run. Everybody summarizes the data. They make your facts into a smaller table, and then the browser or the client requests them. So most of the queries don't run on raw data, they run on a summarized data, which is a much smaller one. And it's not even 100 MB. 100 MB scan actually takes around like 300 to 400 milliseconds on Snowflake too. So it's not something people actually do. But it will not work if you still think that you are in the 1 percentile of the company, where you have actually a lot of data that your customer are using directly, and you want to query a lot of data at once, and also you can't summarize that. And probably the answer will be no, like all of three things will not be true for you as well. But that's not the case with, like, I would say 99 percentile of the company as per BQ itself, but it's quite possible too. So like just a bit of comparison, how does DuckDB Wasm compares with its competitors? Because you would have heard that there is IndexedDB also, there is SQLite also in the browser. So in my opinion, it's like, if not like 600 or 900x faster is the actually. Okay, so who is using DuckDB Wasm? It's a new software. It was, I think, released 2 years back by the people who actually created Google Google Studio, and the one who created like single store is one of another popular in-memory database, and it's been used by a lot of companies: Google, Facebook, Airbnb, even Mode by ThoughtSpot, and of course DevRef too. Yeah, with that, I'm just wrapping up. In case if you want to learn more, these are the references. I will see how I can share these slides with you. But yeah, feel free to connect with me. This is my LinkedIn. This QR code points to my LinkedIn, and this is my Twitter handler. Any questions?